Yeah, good morning. Myself, Prabhakaran J, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is design strategies from Unit 4, that is design and testing. From the subject name is VLSI system design. Yeah, let me discuss. Okay. Design strategies in VLSI testing. It must be planned during the design phase to ensure that manufacturing chip can be easily, efficiently, and truly tested. This approach is known as design for testability, that is DFT. Proper design strategies reduces the cost and increase fault coverage to and ensure high product quality. And followed by we will discuss the principle of test orientation. Um, Already we have discussed controllability and observability. What is controllability? The ability to set an internal node to 0 or 1 during testing, which is called controllability. And second thing is observability. What is meant by observability? The ability to observe the value of an internal node at the primary output. This is called observability. And test enhancement. What is meant by test enhancement? Which means adding hardware structure or reusing existing logic to improve controllability and observability. Okay. Next thing, let me discuss different design strategies, that is ad hoc design testability. A smaller design modification to improve testability. um, Example, in ad hoc testing, it opt for small design testing. So for large circuit, we have to partition into a smaller one, and then we have to do ad hoc testing for that each and every partitioned circuit. The small design modification to improve testability, for example, adding test point, providing extra control signal, then multiplexing input pin for test access. And it has advantages, that is low overhead. Also it has a limitation, that means disadvantages for non-systematic. It is a random test. There is no structured format, so there is no need to follow the documentation, all those things. So there is no need to test design. There is no need to follow test case. So then only this is not systematic. This is become ineffective for large design. And another one is structure DFT techniques. Under the structure DFT technique, we have scan design testing. What is scan design testing? All flip-flop is are connected into one or more scan chains. Here, uh, this is only up to for sequential circuits. This scan based test only uh, for the sequential circuit test. So whenever talk about the sequential circuit, there is memory element is available. So there is a flip flops is are available. All flip flop connected in series in sequential circuits. For example, shift register. This flip-flop here in scan-based testing is replaced by SFF, scan flip-flop. Then enables shifting in test vectors and shifting out captured response. Greatly increase, already we know, greatly increase the controllability and observability. Already we know the what is controllability and what is observability. Here there are a lot of variant. First one is full scan test and partial scan test. Also it has boundary scan test. Next one is built-in self-test. Already we have discussed the circuit test itself using on-chip behavior is called built-in self-test. The test pattern generator and response analyzer BIT controller is the component of this built-in self-test. And next one is boundary scan followed by test point insertion. And let me do one small activity. You have to find the uh, what is the value of this question mark position. Also you can comment the answer. Let me uh, continue the design strategy discussion. um, Next one is test compression. uh, Modern SOCs generate terabyte of test data, so uh, compression is essential. Uh, Here we have some strategies like on-chip decompression of test stimuli, on-chip response compaction, which is signature analyzer at speed testing. Next design strategy is speed testing, uh, which required to deduct timing related fault like transition fault, path delay fault, all those things. And its method is launch on shift. Generally, we call this LO, capital LOS testing, and launch on capture LOC in scan testing, ensuring chip meets performance requirements. And next thing is memory test strategies. Memories occupy most of the chip area in SOCs, requiring specialized test strategies. Uh, Also, we have techniques followed in memory testing strategies, which is March test, March C or March Y, etc. Already. Next one is memory built-in self-test for automated memory test. Next one is built-in self-repair with spare rows columns for yield improvement. And last thing is low power test design. Test may cause expensive switching, leading to overheating the false failure. So, we have followed some of the strategies like power aware ATPG. ATPG, you know, ATPG is nothing but the automation test pattern generation, clock gating during test vector ordering to minimize switch activity. Okay. Next thing is design flow integration. DFT must be integrated into RTL2 GDS2 design flow. Testing strategies are applied at multiple level, RTL level, gate level, and physical design level. Here we have key trade-offs, that is test coverage versus area overhead, test cost versus test time, test performance versus testability. Um, which means a test coverage versus area overhead means more DFT structures uh, leads to higher coverage but increase area. And second thing is test cost versus test time. Scan chain improve testability but long chain increase test time. Performance versus testability. Extra logic may affect timing if not carefully changed. Okay. And the next thing is, yeah, future trends in VLSI test strategies, which is hierarchical DFT for large SOCs with multiple uh, IPs, test access mechanism in 3D ICs, adaptive testing, in-field testing. Okay. Generally, design strategy in VLSI testing revolve around increasing controllability, observability, and automation of test using scan-based testing, built-in self-test, and boundary scan test. Also test compression low power technique, all while balancing cost, area, and performance. These all are the assessment question for this lecture video. What is the main objective of DFT in VLSI design, and differentiate between ad hoc testability technique and structured DFT technique. What is the role of scan chains in VLSI testing? Define BIST and mention its key components. Why is low power test design important in modern VLSI circuit? These all are the assessment for these lectures. If you have any doubt, you can ask me through the comment. We will meet in next video lecture. Thank you.